Hello, this is the continuation to replacement sets for solving equations. So right here we have that x is equal to this expression. So we will do exactly the same thing as we did in the previous videos when learning order of operations. We will just evaluate what this expression is equal to, and they are telling us that x is equal to that expression, whatever we get. So we will find what the value is in a couple of minutes. So we will use PEMDAS again. But as you might recall, we already did an example like this one. Having this division sign like that is kind of writing it like this. 10 plus 3 times 5 divided by 5, 7 minus 6. Like that. So it's kind of putting parentheses for the top portion and then telling you to divide by whatever is on the bottom and kind of putting parentheses around the bottom part as well. And so we will first evaluate whatever is on top or bottom, it doesn't really matter. But whatever we have on top is 10 plus 3 times 5. Using PEMDAS, we see that first we need to do multiplication or division, in this case multiplication. So we will do 3 times 5 is equal to 15, so we have 10 plus 15 is equal to 25. So this is our top. And now we must divide the top by the bottom, but we do not know what the bottom is. So we have parentheses. We will do that first. So whatever is inside the parentheses first, 7 minus 6 is equal to 1. Since there is no operation between the 5 and the parentheses, we know that we must multiply. So this is equal to 5 times 1, and 5 times 1 is equal to 5. So that is equal to whatever goes on the bottom. And if we divide 25 by 5, we find that the answer is 5. So we just replace this whole expression with a 5 right here. With a 5, and we find that x is equal to 5. So x is a variable and we just found its value. Now we will see another example. So it says Dana has $23 in her checking account. After writing a check, she has less than $10. Could she have spent $12, $13, $14, or $15? So first let's see what equation this problem is representing. So we have $23 minus some amount. We don't know what the amount is, and we're trying to find out if it could be one of the amounts that we have listed right here. So does that sound familiar? Yes, it does. This sounds like this is the replacement set, because we will see if any of these values can solve whatever equation we're getting. But now it says after writing the check, she has less than $10. It doesn't say that she has $10. It says she has less than $10. This means that this is less than $10. Something to keep in mind is that 10 is not less than 10. So if 23 minus x were to give you 10, then this statement would be false. Very well, so we can translate the problem into 23 minus x is less than 10. I'm having the replacement set of 12 to 15. So 12, 13, 14, and 15. So now we just did what we did before and replace the 12 and replace x with the 12 and then with the 13 and then with the 14 and then with the 15 and see which ones work. So 23 minus 12, and we want to see if that is less than 10. Well, 23 minus 12 is equal to 11, and that is not less than 10. So 12 cannot be a solution. Now let's try 13. So 23 minus 13 is less than 10. Well, 23 minus 13 is 10. And as I mentioned before, 10 is not less than 10. So 13 cannot be the answer either. Next, we have 14. We have 23 minus 14 is less than 10. 23 minus 14 is 9. And 9 is actually less than 10. Very well, we found one of the solutions. Now let's see if 15 also works, because having one solution doesn't mean that we cannot have more solutions. So 23 minus 15 is less than 10. 23 minus 15 is 8, and this is also less than 10. So this is right. This means that 15 is also one of the solutions out of this replacement set. So the answer to this question would be either 14 or 15.